Okay, this video is about the binomial theorem. It's from chapter 6, section 8, part 2. We already saw the first part was about Pascal's triangle, and this theorem has a lot in common with Pascal's triangle. It's another way to expand binomials. Okay, so the theorem says that if you have a positive integer n in the exponent of a binomial, you can expand it using this pattern. And let's break this pattern down. Well, first let's talk about the a terms. This is really similar to Pascal's triangle. You start with whatever the exponent is, and you count down. The next one is n minus 1, and you keep counting down until you get to where there's a raised to the first power and then a to the 0 power. So let's do an example with that. Let's say this was a plus b to the 10th power. Then this first term would be a to the 10. The next one would be a to the 10 minus 1, which is 9. 10 minus 1. This would be a to the 8th plus dot 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 all the way down until you get a to the 1st plus a to the 0, and you don't really need to write a to the 0 because that's 1, and you don't need to write the first. So that's how the a term behaves. The b term behaves in a different way. This first term in the expansion doesn't have a b. It's b to the 0. The next one has b to the 1, then b to the 2, and it keeps counting up until you get b to the n minus 1, or 10 minus 1, which is 9, all the way to b to the 10th. So this part is unchanged from Pascal's triangle. It's the exact same. But the way the binomial theorem is different is they're saying there's a different way to calculate these coefficients that go in front of these terms. You don't have to use Pascal's triangle. You could use this. N choose 0 would be the first term. So in here, that would be 10 choose 0. Well, if we remember, the formula for this is going to be n factorial over r factorial times n minus r factorial, which is 10 factorial over r factorial, which is 0 in this case, over 10 minus 0 factorial, which reduces to 10 factorial. 0 factorial is 1. 10 minus 0 factorial is 10 factorial. So you have this. 10 factorial over 10 factorial is equal to 1. So that first coefficient is 1. And that's what we would expect it to be. You can actually calculate every coefficient this way. Let's look at this one, the one that goes with this term. That would be 10 choose 10 minus 1, which would be 9. 10 choose 9 factorial. And so that's 10 factorial over r factorial, or 9, over 10 minus 9 factorial, which is equal to 10 factorial over 9 factorial times 1 factorial. 1 factorial is just 1, so this is 10 factorial over 9 factorial, which 10 factorial is the same thing as 10 times 9 factorial over 9 factorial. These cancel out, and we're left with 10. So the coefficient for this term is 10. And if we looked at Pascal's triangle, you would see that is, in fact, 10. That's what that should be. So let's expand some binomials using this. Okay, if we wanted to expand g plus 4 to the, g plus h to the 4th power, well, if we put it in this form, that would mean that a is equal to g in this case, b is equal to h, and n is equal to 4. So let's plug that into this formula. You have 4 choose 0 times a, which is g, to the n, which is 4. Okay, so that's the first term, 4 choose 0. Now the next thing, you have n choose 1. And notice that this counts up. 0, 1, 2, all the way to n choose n. So that means we're going to have 4 choose 1, and then we're going to have 4 choose 2, and then we're going to have 4 choose 3, and then the last term is going to be 4 choose 4. Okay, and now let's add the other parts in here. The a term is going to count down, so we'll have g to the 3, g to the 2, g to the 1, g to the 0, and the b term, which is h in this case, is going to count up. So we have h to the 0 in this one, h to the 1, h to the 2, h to the 3, h to the 4. So this is what g plus h to the 4th expands to. Well, now let's evaluate what these coefficients are. 4 choose 0. Well, anything choose 0 is 1, but let's see that in the formula. 0 factorial over 4 minus 0 factorial. Okay, you get 4 factorial over 0 factorial is 1 times 4 factorial. 4 minus 0 is 4. And then these cancel out, and you're left with 1 over 1, which is 1. So this coefficient is 1. So we just have g to the 4th. Well, similarly, let me get some more space. 4 choose 4 is also 1. Anything, when you choose the total number of them, there's only one way to choose 4 things out of a group of 4 things. But if we look at the formula, you can see that also. That would be r factorial, which is 4 factorial, over 4 minus 4 factorial. And you get 4 factorial over 4 factorial times 0 factorial. This is 1. And then 4 factorial over 4 factorial also gives us 1. So this last term, 4 choose 4, is also 1. So we got all this stuff in between of g to the 4th and h to the 4th. Let's calculate 4 choose 1. Okay, so 4 choose 1 is going to be 4 factorial over 1 factorial times 3 factorial, because it's 4 minus 1. And you get 4 factorial over 3 factorial, which is the same thing as 4. These cancel, and you're left with 4. So 4 choose 1 is the same thing as 4, and then we have g cubed times h. Now we need to calculate what is 4 choose 2. Okay, so we have 4 factorial over 2 factorial times 2 factorial. So these two 2 factorials cancel out. 2 factorial is just 2, so I don't actually need to write that. 4 divided by 2 is 2. So we have 2 times 3, which is 6. So we have 6 times g squared h squared. And if you do 4 choose 3, you will get 4 times gh cubed. And this is the same thing as what Pascal's triangle would give us. Let's do c minus 2 to the 5th. Okay, so you have a is equal to c, b is equal to minus 2, and n is equal to 5. We actually already expanded something like this using Pascal's triangle, but now we're going to use the binomial theorem. And I don't have it written here because you should be able to do it without the binomial theorem without looking at it, because it's always n choose 0, 5 choose 0, times a, which in this case is c, to the n, plus next one would be 5 choose 1 times c to the 4th times the b term to the first power now, and then the next thing would be 5 choose 2 times c. Let me not write parentheses because it looks like c and c. So times c to the third power times b to the second power plus 5 choose 3 times c to the second power, counting down on c, times b to the third power plus 5 choose 4 times c to the first power times b to the fourth power plus 5 choose 5 times c to the 0 power, which is just 1, and then times b to the 5th power. Okay, now let's go ahead and simplify. 5 choose 0 is 1, so the first term is just c to the 5th. 5 choose 1 is 5. That's going to be c to the 4th times negative 2. 5 choose 2 is 10. And you get c to the 3rd times negative 2 squared is 4. Plus 5 choose 3 is going to be 10 also. So we get 10 c squared, negative 2 times, to the third power is negative 8. Plus 5 choose 4, which is going to be 5 again, times c. Negative 2 to the 4th is going to be 16 times 16. And then plus 5 choose 5, which is 1. And negative 2 to the 5th power is going to be negative 32. Okay, so now let's simplify even further. C to the 5th plus 5 times negative 2 is negative 10. So minus 10 c to the 4th. 10 times 4 is 40, so plus 40 c to the 3rd. 10 times negative 8 is negative 80, c squared, plus 5 times 16 is 80, c, and then plus negative 32, which is minus 32. And this is the expansion of c minus 2 to the 5th, and it's the same thing that we got from Pascal's triangle. So let's use the binomial theorem in one more type of example. The nice thing about the binomial theorem is you don't need to expand the entire thing. If you were just interested in one term, let's say you were interested in the fifth term, well, the first term is n choose 0, the second term is n choose 1, the third term is n choose 2, the fourth term is n choose 3, and the fifth term is n choose 4. I didn't need to write all that out. I should know that the fifth term is going to be n choose 4 because it's always whatever term it is minus 1, since you have this n choose 0 here. Okay, so let's use that fact and the relationship between n and the number that you're choosing. Let's go back and look at the binomial theorem. Okay, so let's look at the patterns that we see here. If you have n choose 4, because we're interested in the fifth term, for example, well, you'll have a raised to the n minus whatever this number is here, so n minus 4, and then you'll have b raised to whatever this number is, b to the fourth. You can see that pattern here. A is raised to the n minus this number, and b is raised to that number. Then here you have a, n minus 2, b to the 2. A raised to the n minus 1, which is just 1. n minus 1 is the same thing as 1, okay? And then b raised to the n minus 1. So the exponent that goes with the first term is this minus that, and the exponent that goes with the b term is whatever the number you're choosing is. So let's go use that in this word problem. Okay, so let's use that for this problem. Okay, let's say that a player makes 90% of her free throws. We're going to assume that as the probability that she makes a free throw. So probability that she makes a free throw is going to be equal to 0.9, 90% of the time. The probability that she misses, I'm going to call that brick, a B. Probability that she bricks the free throw is 10%, or 0.1, okay? So we want to find the probability that she will make exactly 6 out of 10 free throws. So we're interested in this. She shoots 10 free throws. We want to choose 6 makes. So this 6 goes with the makes. So we'll put that here. So now we need to put our exponents. What we have here is we have the probability that she bricks it plus the probability that she makes it, and she's shooting 10, okay? So each of these adds up to 1. 0.9 plus 0.1 is equal to 1, and 1 to the 10th is equal to 1. So there's a 100% chance that she either makes or misses each of the 10 free throws. All right, so in this case, 10 choose 6. This is really the only case that we're interested in. She shoots 10 and she makes 6. So we want this to go with the make. So we have the probability that she misses. How many did she miss? She missed 4 if she made 6, times the probability that she made it, and she made 6 of them. Well, if you look at the formula for the binomial theorem, you have n choose 6. This is 10 minus 6 is 4, and then the exponent here is 6. This will calculate the probability that she made exactly 6 free throws. Okay, so 10 choose 6. Let's calculate that. 10 factorial over 6 factorial times 4 factorial is 10 times 9 times 8 times 7 times 6 factorial over 6 factorial, 4 factorial. The 6 factorials cancel out. Okay, and now let's expand out this 4 factorial. That's the same thing as 4 times 3 times 2 times 1. Okay, 4 times 2 is 8. So I can cancel out this 8 with the 4 and the 2, and then 9 divided by 3 is 3. So I can reduce this problem to 10 times 3 times 7, which is 30 times 7, or 210. So 10 choose 6 is the same thing as 210. And then I can do 0.1 raised to the 4th. That should be 0.1. And 0.9 raised to the 6th. 0.1 raised to the 4th, well, 0.1 is 0.1 times 0.1 times 0.1 times 0.1. Well, the nice thing about that is 0.1 times 0.1 is 0.01, times 0.1 is 0.001, times 0.1 is 0.0001. So 0.1 to the 4th is 0.0001. So now I have 210 times 0.0001 times 0.9 raised to the 6th. 0.9 raised to the 6th, I'm going to go ahead and use a calculator for that. 0.9 to the 6th, 1, 2, 3, 4, 5, 6, is equal to 0.531. Now if I multiply that times 0.0001, I get 0.000053, and then I multiply that times 210, and I get 0.01. This is the probability that she makes exactly 6 out of 10 free throws if she's a 90% free throw shooter, which is what you would expect. She's probably going to make more than that, and making exactly 6 is relatively unlikely. So there's a 0.01 or a 1.116% chance that she makes exactly 6 out of 10 consecutive free throws. So that's pretty unlikely. All right, let's do one more problem like this. What's the probability that she makes exactly 9 out of 10? She's a 90% free throw shooter. What's the probability she makes exactly 9 out of 10? This is where probability is kind of tricky. You might expect this to be really, really high, and it's not. So you have 10 choose 9. That's a 9 in case you can't tell. This is what we're interested in. And she's going to make 9. Well, the probability that she makes one is 0.9. She's going to make 9 of them, and she's going to miss 1 of them. And if you do 10 minus 9, you get 1, and then 9 is the exponent that goes here. So this is using the binomial theorem correctly. 10 choose 9 is going to be 10. If you have 10 factorial over 9 factorial times 1 factorial, same thing as 10 times 9 factorial over 9 factorial, you get 10. So we have 10 times 0.1 raised to the 1 times 0.9 raised to the 9. 10 times 0.1 to the 1, that's the same thing as as 1. 10 times 0.1 is 1. So this really reduces to 1 times 0.9 to the 9, which is just 0.9 to the 9. And that is the same thing as 0.387. So it's approximately 38, this is an approximation, it's approximately equal to 38.7% chance that she would make exactly 9 out of 10. If you're curious as to why this number is it seems kind of low, you know, she's a 90% free throw shooter, you would expect her to make 9 out of 10. Well, it's actually the highest probability for making exactly any number out of 10, but it's still relatively low. The reason why is all of the probabilities, the probability that she makes exactly 0 of her shots, plus the probability that she makes exactly 1 of her shots. So I'll say the probability that she makes 0 plus probability she makes 1 plus 2, all the way up to the probability that she makes 9. Okay, these are all the possibilities. She could either make 0 shots, 1 shot, 2 shot, all the way up to she could make 10 shots. These are all the possibilities. Well, all those possibilities have to add up to 1. You can't have a probability higher than 1. So all these individual probabilities, the probability that she makes exactly any of those adds up to 1. So this 38.7% here, or 0.387, is the highest of all of these individual probabilities, but it's still not that high. 38.7% chance that she makes exactly 9 out of 10. Anyway, that's kind of an introduction to probability for you to see later. As an exercise, you can see the probability that she makes all of her free throws. That would be 10 out of 10, and you'll see it's lower than 38.7% chance, which also makes sense. So that's it for this lesson.